Okay, one problem involving friction. In this problem, as you can see, there's a crate and 80 Newton force is applied to it. There will be two scenarios for motion. One scenario will be the block moves to the right. The other scenario will be the block tips over. So I need to consider both scenarios. So let's work on scenario 1. You have 80 Newton force there. When the force applied, there is going to be a friction. And that friction is opposite to motion. In this case, the friction would be like this. I'm going to call this F of F. Every friction comes with a normal force. Remember, normal force is perpendicular to the surface and then moving to the object. So in this case, the weight is 20 kilogram. So I have a mass of 20 kilogram in the center here. So that will make it 20 times 9.81. Okay, if I want to calculate the friction for this motion, I'm going to get sum of f of x equal to 0 and sum of f of y equal to 0. 80 Newton, the angle for this is 30 degree. So if I break it down, I'm going to get 80 sine on the y and 80 cosine on the x. So again, basically, we are looking at this as a particle, right? With some forces on it. We have 20 times 9.81 here. You have the normal force this way. And then, in this case, we have 80 cosine 30. And then we have 80 sine 30. I'm just bringing that force of 80 Newton down. And then I have the friction this way. F of F. So if I write sum of f of x equal to 0, sum of f of x equal to 0, I'm going to get f of f minus 80 cosine 30 equal to 0. From here, the friction force is equal to 80 cosine 30, and the answer for this is I got 69.28. I'm going to just say the 69.3. Okay, so this is the actual friction, right? This is the actual friction that comes from pushing with the 80 Newton. So I need to compare this actual friction with the maximum friction. This is the actual one. The actual friction. I need to compare this with maximum friction. Okay, if the actual friction is more than maximum friction, it will move or not? So it will move, right? If it's less than that, it will not move. So let me just to calculate the maximum friction. F max is equal to mu s n. The mu s is given to me as 0.3, but I don't have n. So that's where I need to do sum of f of y as well, right? To calculate n, I'm going to do sum of f of y. So sum of f of y equal to 0. I have n minus 20 times 9.81 minus 80 sine 30. From here equal to 0. From here I'm going to get n is equal to 20 times 9.81 plus that will be 236. Do you remember some of you said that normal force is weight, which is not weight. In this case, the weight is something else, right? Weight is 196.2 if you do that, right? But your normal force is much more. Why? Because a portion of this force P is pushing the block down, right? It's not only the weight, the portion of the force that I apply, that's pushing the object down too. So I have the normal force, then I can use that equation. So I'm going to say F of max is equal to 0.3 into 236.2. 0.3 times and I'm getting 70.86. Am I safe or not? Based on my calculation, the friction that I have, the actual friction is 69. The maximum friction is 70.86. Am I safe or not? No or yes. You see, the maximum friction is 70. The actual friction is less than that. Will not move. Will not move to the right. Right? So we know in scenario 1, will not move to right, because your actual friction is less than F max. So I need to work on scenario 2. Scenario 2 is about tip over. So tip over is about distances, right? In this case, you can see I have a distance of 0.2 to the floor, distance of 0.8 in the other side. So if that block wants to tip over, again, I'm going to a little bit exaggerate on the shape. So it's going to look like something like this. Remember, I'm exaggerating, right? Not going to be this much. So this guy will go like this. I have I guess I exaggerated too much. Let me just to have it a little bit tilted. Okay, this is the tip over scenario. In the tip over scenario, we had two forces, right? The forces that, so this was 80 cosine. The distance from here to here is 0.2. The distance from the middle of this, we have the force weight right here. That weight is 80, no, was 20. No, I need one. So if you look into the tip over scenario, right, everything will be coming to this corner. At this corner, we're going to have a friction and a normal force. We don't care about that friction. We don't care about that normal force. But again, that will be we are caring about the tip over. So among the two forces that I have, I need to see what forces is doing what, right? So this 80 sine 30, that wouldn't do any much of work. The force that creates the rotation is the force of 80 cosine 30. Do you agree with me? That creates the rotation. So that creates what type of rotation about this tipping point? A clockwise rotation, right? So I'm going to call this P, and I do sum of moment about P. Sum of moment about P is equal to, I have 80 cosine 30 times 0.2. As I told you, this doesn't create moment, right? Because there is no touch for it. So, and then the other thing that I have is 20. So this will be a clockwise moment, and I have a counterclockwise moment. Plus 20 times 9.81. So if the sum of this becomes, like again, if the moment that I apply, as you look at the weight is 20 times 9.81. What's the distance for that? Is the half of the distance up there, right? Whole distance was 0.5, and then that distance will be 0.4. Actually, you see there is an edge here. The other force will create the moment too. This 80 sine 30, that will create a rotation because there was an edge there. That edge will create a rotation. So the 80 sine 30 will create the same rotation as 20, right? I'm going to add that to the equation. 20 times 0.4. And then we have the other one plus 80 sine 30. That will be times distance of 0.8 for the rotation about this point. So I'm going to calculate this sum to see whether this sum is positive or negative. And then from there we can do our judgment. So I have 80 times this times 0.2. For the first portion, I got 13 point. For this portion, I got 13.856. That's negative. So this one, I got 78. So again, if you just consider this, all of this is greater than 0, right? So meaning that this will not tip over. This will not. And this is our scenario too. Yeah, because you see, because of the direction of the rotation, the AD cosine 30 about point P is going to go clockwise, right? Let me just to change my pen and show you why. Yeah, so AD is going to go clockwise about point P, right? AD cosine 30. But AD sine 30, those going to go counterclockwise. That's why they are positive. Now, because the sum of moment is positive, this means that the object will stay on the floor. It will not tip over. It will tip over if the sum of moment was negative. But in this case, will not tip over. That's our scenario 2. Now, it's not going to move to the right, and it's not going to be tipping over. So the question is to determine if it remains in equilibrium. Yes, it is. So based on 80 Newton, it will remain in equilibrium. It will not move. So let's look at another problem, like very similar to what we solved. In this case, I have a crate of 80 kilogram. That's the center of gravity. Determine the smallest force will initiate motion. Again, I need to consider two scenarios. So, two scenarios. Scenario 1 will be, okay, if there is a motion will be in what side? Motion to left or to right? Based on the force that I apply. Right. Exactly. So scenario 2 will be scenario of tip over. I'm going to tip over about the point here. About that point. Now I will start working on to see what the forces are doing. So I have a force P. This is the 35 degrees. I need to consider two scenarios as we discussed. So scenario 1, I have the crate. The weight of the crate is 80 into 9.81. I have a normal force from the floor. Okay, the object wants to move to the right. The friction will be to the left. Force of the friction is to the left. And I have one more force P there. And that P, I want to define that P to see how much that P is. So let's just start doing the same calculation, right? So the first thing I do for this thing to, again, right now the question asks me how much the force P would be. So the F of F has to go to max for this thing to move, right? F of F will be equal to F of max is equal to mu S N. The question, did they give me mu S? Yes, they give me at the bottom there. It will be 0.3 N. I will consider that in my equation. So let's do sum of F of Y. Sum of F of Y equal to 0. From here I have P sine 35 going down minus AD into 9.81. That's moving down plus N. And then on the Y, on the Y already calculated, on the X, I have F of F, which is 0.3. So it will be P cosine 35 minus 0.3n equal to 0. From this equation, I can find n in terms of the other one. So I'm going to say n is equal to p cosine 35 divided by 0.3. The answer for this, so cosine of 35 divided by 0.3, the answer is 2.73. So 2.73 p. So I'm going to bring this to this equation and solve for p. So I have minus p sine 35 minus AD into 9.81 plus 2.73p equal to 0. So you can bring this one to the other side, and then in this side you're going to get p minus 2.73 minus sine 35 is equal to AD times 9.81 . Okay, I got 785 almost. 785 in this side. Then you can get P is equal to, I need to calculate here. There's a dot here, right? 2.73 minus sine of 35. I got 2.1 here. 2.156. From here, we're going to get P is equal to 785 divided by 2.156. The answer is 364. Just need to check the unit for this. 364 Newton. So if I apply 364 Newton, this will move to right. This is scenario 1, right? Scenario 1 telling me that if you apply a force of 364, this block will move to the right. So the second scenario, the scenario of tip over, I'm going to go and draw the diagram for tip over. Again, you do a little bit of the tip over, something like this. So the tip over, it depends on the distances, right? We have two forces. We have the force of gravity here. The force of G, which is gravity, is 80 times 9.81. G is the center of gravity, by the way. Then we have the force P here. That's the point P. And then we have another force up here with the angle of 35 degrees going down. I'm going to break down the force P in two components. One I'm going to have here, P cosine 35. I'm going to have P sine 35 here. Remember, if we tip over, which one of these forces will have moment about point P? Let me just to change this point to another point. Point P will be a little bit confusing. Point O. P sine 30 or P cosine 30? Distance, yeah, P cosine has moment, and the distance in there is the distance from here to there is 1.8. Again, if you look into this distance from where the force is to the point down there, so this is the force, this is the point, right? From that force to that point, we have distance of 1.8. So I'm going to do sum of moment about O is equal to P cosine 35, the distance for that is 1.8. Then this is going to go clockwise, by the way. This is clockwise based on my diagram. The second force is this force, which is counterclockwise, the course of the weight, and the distance down there is 0.6. So I'm going to get minus, again that will be plus 0.6 into AD cosine. Again, AD cosine, this actually was 785, right? Time 785 I'm going to put equal to 0. Okay, the 0 meaning that that will be the moment of the tip over. Right? If we go a little bit more on the P, we'll start the motion. So in this case, I'm going to calculate P. So come back. So I'm going to get P is equal to 0.6785. No, if you look at the point O here, the gravity is going to go counterclockwise. Right? But the P cosine 30, that's going to go clockwise. Again, I brought it to the other side, then I actually have the negative here. So that's how I got it. So let me just to see how much I'm going to get here. 0.6 times 785 divided by cosine 35 divided by 1.8. I'm going to get 319. So which one of these scenario will happen? If I apply 319 Newton, it will tip over, right? If I apply 364 Newton, it will move to the right. Which one of these will happen first? Can anybody answer my question? So exactly, because once you reach to 300, it's already tip over. It's not going to move to the right at all. If you look at the crate, it looks like a large crate, right? You're applying the force to the top of it, it will tip over. But again, I'm talking about rationally, right? But based on our calculation, at the end, we got it for the tip over scenario. So you can say block or crate will tip over first with force of 319 Newton.